Okay, here we go. I'm going to show you the answers to these practice problems. I hope that you did the same thing when you were in your groups. You had to say what times 5 equals 10. If you didn't pick up that that was a times 2, right? If you didn't know that was 5 times 2 is 10, and hence do the same thing on the top, times 2, whatever you do to this, you have to do the same thing on these tables. 1 times 2 is 2. If you didn't know that, you can always go in the reverse order. 10 divided by 5, right? 10 divided by 5 is 2, and that would have gotten you this answer of 2. You can type those into the table as well, as I have done. Next problem. What am I multiplying by to get to 24? If I am not sure what I'm multiplying, 8 times blank equals 24. 8 times blank equals 24. If I don't know the answer to that, I can always go backwards. 24 divided by 8 equals blank. In this case, it's a 3. So if there's a 3, 8 times 3 is 24, then 3 times 3 is 9. That's my table. I can put it in this table over here if I want to type it in instead. Either one is fine with me as long as I can read what you're writing, right? Some people can write on these and some people have a harder time writing. So same thing, I'm going to look for patterns. What am I doing to get from 5 to 15? I'm multiplying by 3. If I didn't know that, I would say 15 divided by 5 is 3. 15 divided by 5 is 3, so 5 times 3 is 15. If I multiplied by 3 there, I'm going to have to multiply by 3 here. 6 times 3 is 18. How do I get to 36? So I can do this two ways. Maybe you know that 18 times 2 is 36, in which case you're also going to do times 2 on the bottom, which would be 30. But maybe you didn't know that, right? Maybe you didn't know that. Oops. But you do know, let's keep going back a little bit. You do know that 6 times 6 is 36 because you know that times table. You can do that, you can do that too. 5 times 6. It's okay to skip 1, is 30. So either way, you'll come up with the right answer. You're looking for the patterns that you know. There's no right way to do this. There's no wrong way. There's lots of ways. You are mathematicians, and you have so many ways that you can solve a problem. So I'm going to put it in my table, 5, 15, and 30. So if there is a ratio of taxis to buses in some particular city, and there's 36 taxis, there will be 30 buses. Okay. Hamburgers to hot dogs. The ratio of hamburgers and hot dogs is 3 to 5. Remember, just as a review, you can write it as 3 to 5, or 3/5, or 3 to 5, right? So the ratio of hamburgers to hot dogs is 3 to 5. What do I do to get from 5 to 10? Now I'm doing the bottom first. To get to 5 to 10, I multiplied by 2. I see that pattern. So I'm going to do the same thing on the top. I multiply by 2. 3 times 2 is 6. So we're filling out a ratio table looking for all of those patterns. How do I get from 6 to 9? That's one of those hard ones. How do I get from 6 to 9? There's a couple of ways you can think about this. You could either go all the way back like we did last time, where we have 3 times 3, go all the way up to the top, 3 times 3, in which case we're going to do the same thing on the bottom, times 3. And 5 times 3 is 15. So that's how you could fill out that ratio table, doing it that way. Another way that you might notice that 6 plus 3 is 9, and 5 plus 10 is 15. So if you add the 2 and get to 9, that's another pattern that I see that will also work. So I just put in some blank tables on some of these, so you would have to write burgers and hot dogs And I just put initials just to make it go a little faster. That would be 3, 6, and 9, and 5, 10, and 15. All kinds of patterns. Mathematicians love looking for these types of patterns. Okay, now what did I do to get from 14 to 7 or from 8 to 16? What do you notice? I noticed that to get from 4 to 7, I had to divide by 2. If I wasn't sure of that, I would say what is, or 2 times 7 equals 14, or 7 divided by 14 is 1 over 2. I would have said is 1/2, which is the same as dividing by 2. So I divide by 2. If I divide by 2 to get 7, I have to divide 8 by 2 to get 4. Now I got to get up to 16. What can I do to these numbers to get to 16? I see a couple different patterns. I could multiply by 4, because 4 times 4 is 16, or I could multiply the 8 times 2, whatever you prefer. If I do 7 times 4, I get 28. Also, if I do 14 times 2, I also get 28. So my answers here are towels and towels and blankets. And I have 14, 7, and 28. So you are looking for patterns in everything on these tables. Lots of ways to see patterns. Okay? I'm going to go back here just for a second. Probably not the easiest pattern. There's other ways to see patterns. When we come across them, we will talk about those. So number 6, how do I get from 16 to 8? Well, that's half as much, right? So I divide by 2. So if I divide the top by 2, I divide the bottom by 2, I get 6. I get 5. 10 divided by 2 is 5. How do I get to 30? I could either do 6 times 6, right? Or I could do 10 times 3. Your choice. You pick the pattern you like. If I did 8 times 6, 8 times 6, my goodness. 8 times 6 is, let's see, 6 times 6 is 36, and another 12 is 48. So sometimes if you just have a moment where you can't remember what 8 times 6 is, go with what you know. There's nothing wrong with that. Okay, so these are forks and spoons, and we have 16, 8, and 48. 10, 5, and 30. So you're checking all of your answers. Number 7, for every 3 tickets you sell, your friend sells 4. You sell a total of 12 tickets. How many does your friend sell? So now, if you were given this story problem, so we're going to read it 3 times. I read it once. Now I'm going to read it again. For every 3 tickets I sell, so there's a number 3, your friend sells 4 tickets. You sell a total of 12 tickets. So now I start thinking about the quantities I know and the relationships between them. I know that I sell 3 tickets and my friend sells 4 tickets. So the ratio is 3 to 4, right? But I know that I sell a total of, or 3 to 4, and I know my total is 12. So whatever happens here, this is my relationship. These are my quantities. So I have a quantity of 3 and 4, but I know I have to get up to 12. So what do I have to do to get from 3 to 12? Well, I might notice right off the bat that I could just skip all these steps and what I can multiply, or I might count by 3s. 3, 6, 9, 12. I added 3 each time, right? If I'm skip counting or adding 3 each time, I'm going to have to skip count on the bottom, but not by 3 because there's 4 of them. Four plus 4 is 8, plus 4 is 12, plus 4 is 16. Because our ratio was 3/4, I have to add 4 each time. So that's another way that you can look for a pattern. If you're adding the same thing each time, or if you're multiplying by something to get to the next spot. What am I multiplying by to get from 3 to 6? I'm multiplying by 2. Did I multiply by 2 on the bottom to get from 2 to 8? I did. Also, multiplied by 2. If I would have done the whole thing all at once, I know there's a lot of colors going on here. If I would have done the whole thing to get from 3 to 12 all at once, that's just multiplying by 4, right? So what is 4 times 4? 16. So many patterns that I see. That is what's so fun about these ratio tables. Oh my gosh, I love ratio tables because there's just so many ways you can do them. So fun. I spelled friend wrong and you wrong. 3, 6, 9, 12. So I added 3 each time. If I add 3, I have to stick with my ratio and add 4 on the bottom. If I'm adding, I have to add the ratio amount. If I'm multiplying, they have to multiply exactly the same on the top and the bottom. That's where it gets a little bit confusing when we add or when we multiply. If you add the ratios. If you multiply the same. Okay? A little tricky. All right. Next one. A store sells 2 printers for every 5 computers. The store sells 40 computers. How many printers does the store sell? So eventually, you're not going to be given the table to set up. You're going to have to set it up. So immediately you would set up your you would start to set up your table. You would write printers and you would write computers and you would put the 2 and the 5 because as I read my problem, I see that those are 2 quantities that I know and that the ratio is 2 to 5. So I set up my ratio and then I just put out my table as far as I think I need it. Right? If you don't need it to be this long, if you can, and let's do it in red like I did a second ago, if you can go all the way to 40, 5 times what? Then you can do that with skipping all those steps, right? And you can just put the same thing in. We'll come back to that. Let's see if you can figure it out. In the meantime, I'm going to go from 2, 4, or 2 times maybe 8, 4. I'm going to double this. If I double the 5 to 10, if that was times 2, then I have to double from 2 to what? Times 2 is 4. 4 times 2 is 8. So if I, times 2, not 8. If I multiply times 2 on the top, I have to multiply on the bottom. So I get 20. And to get from 20 to 40, I multiplied by 2. So I'm going to have to multiply by 2 on the top again to get 16. So I would have sold 16 printers when I sold 40 computers. Okay? Now, could have I just added 2 each time? I could have, right? I could have went 2, 4, 6, 8, 10, 12, 14, 16, and then I could have went 5, but I have to multiply, I have to go by 5s now. 5, 10, 15, 20, 25, 30, 35, 40. And I would have got to 16 and 40. There wasn't as many places in my table to do that, but I could have. If I prefer to do skip counting, as long as I always add 2 on the top and add 5 on the bottom, you can fill out a table that way. Either way, totally fine. Okay, problem number 9. First and second place in a contest use a ratio to share a cash prize. When first place pays $100, second place pays $60. How much does first place pay when second place pays $36? Uh-oh, now I'm going the other direction. Now I have to figure out what happens the other direction. Okay? So how am I going to get to 36? Boy, that's a hard one, right? How am I going to get from 60 to 36? Well, I'm not dividing by 2. What kinds of things am I doing? What could I do? One thing I know is 6 times 6 is 36. and I see that there's a 6. So I might notice a pattern. What if somehow I could get a 6 here? If I could get a 6 here, then I could get to 36, right? I could get times 6. And it looks like I can get a 6 here because I can divide by 10. So that's one way that you can do it. And if I divide by 10 on the bottom and I divide, then I divide on the top by 10. 100 divided by 10 is 10. 10 times 6, I have to do the same things, is 60. So my question, how much does first place pay when second place pays 36? First place pays $60. By the way, when you have a story problem like this, you should always answer it in a sentence. So my answer would be first place, and I wish I would have put, and I will, on yours, I'm going to put some text boxes. So then you'll have to answer in a sentence. If it's a story problem, first place pays $60. Always put your units, $60, when, and this is why typing is good because you could actually read my writing. Second place pays $36, right? So not a lot of space. That's why I'm going to give you guys a text box. Okay. Number 10. A grade has 81 girls and 72 boys. The grade is split into 2 groups that have the same ratio of girls to boys as a whole grade. How many girls are in a group that has 16 boys? What do we know? Is there anything that you see any patterns to? Do you see any patterns? 72. I know that 9 times 8 is 72, and I know 8 times 2 is 16. So if I can get an 8 in here, then I think I can do it. So if I divide the first time by 9, and I divide the top by 9, of course, because I'm going to do the same thing each time. 81 divided by 9 is 9. Then I multiply by 2, because 8 times 2 is 16, and I multiply by 2. I'm getting to my puzzle. 9 times 2 is 18. So if a grade has 81 boys and 72 girls, the grade is split into groups that have the same ratio of boys to girls. How many girls are in a group that has 16 boys? So my answer would be there are 18 girls in the group, or in a group, with 16 boys. All right. Looking for patterns. That's what mathematicians do. We're doing a fine job. Next problem, find the error. Love these problems. What can possibly go wrong? What is happening from 3 to 8 and then from 8 to 13? And 7 to 12 and 12 to 17? Well, if they were doing the ratio method and they did plus 3 on the top, they would have 6, not 8. Or plus 7, they would have 14, not 12. So I don't think they're doing the adding method. What are they doing? So as I look at this, what do we notice? We notice that 3/7, well, let's do this. 8/12, sorry. If I had the fraction 8/12, and I were to divide the top and the bottom by 4, I would have 2/3. 2/3 is not the same as 3/7. This ratio table is not a ratio table. There's nothing that I can multiply to get to the next thing that I also multiply. In order to, let's just show you what I'm talking about. In order to get from 3 to 8, I actually have to multiply by 8/3. Okay, so if I multiply 3 over 1 times 8 over 3, I get 24 over 3, and when I simplify, that equals 8. Okay, so 8/3. Now, if I multiply the bottom, 7 times 7 over 1 times 8 over 3, and we know how to multiply fractions because we've been doing that. 7 times 8 is 56 over 3. And when I simplify 56 over 3, I get 18 and something. So it is not 12. So this is not a ratio table. So I would type, this is not a ratio table. This is not a ratio table, since there is nothing I can multiply to get to the next set of numbers. Okay, another error. Find the error. Oh my gosh, don't you love these? At least these ones I can kind of see some patterns, right? So from 5 to 25 is times 5, and 5 to 2 is from 125 is also times 5. 5 quarters gets me $1.25. And on the bottom, 3 times 3 is 9, and then another times 3. Notice what they're doing. So we talked about the two different ways you could find a ratio, or you could fill out this ratio table. If they would have added these, if they would have done a +5 and a +3 and kept going all the way out to 125, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, all the way out to 125. And on the threes, if they would have done 3, 6, 9, 12, 15, blank, 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 all the way out to 27, then it would have been okay. But because they were multiplying by a 5 on top and multiplying by a 3 on the bottom, they can't do that. So you cannot multiply by two different numbers. On top and bottom. You can add to the top and bottom the number that is the same as the ratio. I'm going to come up with a really good way to tell you guys that in class, so I hope this comes perfectly. Okay, are we done? We are done. You guys rock.